think about how important the work we're doing here is, right? Been on the leading edge, solving this huge problem to make data work. And it's a cross-industry problem. It's a global problem in all application segments. And this group and the technology that the community has built is one of the, if not the premier solutions out there. But the work's not over. We have to keep going forward into these other segments. So with that, I want to introduce our next speaker. Now, he's got a really good bio here, and I'm going to read it. But here's the most important thing to know about Milan Milenkovic. He is our very first returning second-time keynote speaker. And that's pretty interesting how that happened, and I'll tell you more about that. So let me tell you a little bit about Milan. He's a principal and founder at a company called IoT Sense out in the San Francisco Bay Area. Before that, he was a principal engineer at Intel. And he was involved in IoT, distributed systems, smart buildings, and energy management. And before Intel, he worked at IBM and also in academia. And he's been involved in systems research and always on the leading edge with emerging technology. He's invited speaker to many events, industrial conferences, academic events, et cetera. He has a Master of Science degree in computer science from Georgia Institute of Technology and a PhD in computer engineering from the University of Massachusetts. And he's authored numerous papers, holds numerous patents, and one of his books is Operating Systems, Concepts, and Design. He's a member of ACM and a distinguished engineer, and a senior member of IEEE. And in 2015, we invited him to join us at Haystack Connect in Denver. And again, it's actually the truth, we had no idea what he was going to talk about, but we knew he was a very recognized person. And one of the things he stunned us with was tell us, oh yeah, I've been using Haystack in the lab because it works, because it solves these problems. So that was pretty interesting serendipity at that time, and we're really glad to have Milan back with us. As I said, 2 years has taken us further down the road, and really excited to hear his insights. So Milan, if you would join us.
I'll leave it with you. Thank you. Good morning, everybody. One of our missions is make sure that I don't come here the third time. That would be too much. So I apologize. I was preparing a little bit longer presentation than we have the time for, so there are a few bills. I apologize in advance for that. But basically, so I'll just quickly through that. The sort of narrative of my talk today is I've been preaching the virtues of interoperability and Haystack and stuff like that for a long time. And I'm now convinced that we should reduce that to practice. And so here is a proposal and call to action in terms of why it should be done and how to do it. And so basically, I'll just talk about the IoT semantic interoperability, try to define it a bit more precisely, discuss why it is important, why the world believes and why it isn't, and sort of some ways of how to go about that. A little bit light on the technical side, because I believe that Haystack is a good foundation that can be built upon. So it's really, what to do with it. Okay, so one of the things, there's a lot of discussions of interoperability. I'm a co-chair of the semantic working group of IPSA. And we've been talking about interoperability for months now in this work group. And only recently, after forcing the issue, have we found out that we were really talking about two different levels of abstraction. Using the same words and arguing the same things, but really meaning different things, which of course we couldn't possibly convert. So at least now we have that realization, and we'll go from there. So before I show you that, this is my generic picture of the Internet of Things that I like to use to introduce it. At the bottom are the various use cases. Rita mentioned some, and these are the ones actually practiced with the Internet of Things. And by Internet of Things, I mean connecting sensors, sensing things in the real physical world, but using Internet style and techniques and technology and connectivity. This is similar functionally to the systems we've been doing for a long time in industrial automation, but it does use Internet. So all the embedded and firmware people there, it's not exactly the same. There are some bad habits that should be left behind. So, and as I said, it sort of from the Internet point of view, it's very interesting because it brings really the real physical world dimension to the internet, in addition to all the virtual stuff. So it adds a tremendous component. So it's a transformative change and an inflection, but I won't belabor that point much. So a level above the usages is the sort of typical sensors. You have your sensors and gateways as we are accustomed to. The new thing is smart sensors that have the horsepower and connectivity to connect directly to internet. And two things that I have highlighted there to the left is the smartphone. Think of the smartphone, it really is the gateway with about on the order of 10 or more sensors that have connection to the internet. You have the processing power and the storage, and you have the UI, right, to interact with the user. So it's a very powerful thing that can be expanded upon and is used from the sensing point a little bit less than it can. It's more application specific. And to the right is just to remind you that sensors can be added to the existing infrastructure. We have done a very interesting project where we added sensors, temperature, humidity, and energy to PC infrastructure and realized that that's relatively inexpensive because the infrastructure is in place. The connectivity, storage, and user interface and processing power is all paid for already by the infrastructure. So we are just adding the cost of the sensor and adding more interesting features. Just a reminder. And then, of course, sensor data is sent to on-premises servers or servers in the cloud, internet basically, where the large-scale data processing takes place, and it could be a federation of databases from different domains, but then you want to be able, if you really want to do machine learning and optimizations and artificial intelligence, they work better with the large diverse data sets, where you can make the connections about the similar systems and see the patterns across the systems, discover those that you may not be aware of, right? That's their power. But in order for that to work, the data have to be interoperable. They have to understand what the data from different systems means, right? Right now, that's not the case. They are fragmented. So back to the topic, okay, so what are the levels of interoperability? There are at least two important levels to think of. One is sort of the machine-to-machine that has been around for a long time, where the sort of the objective is for the devices to be able to talk to each other directly and to almost be able to do that at understanding each other's not only semantics, but also syntax, basically able to issue the controller and talk to each other. And this is typically, there are many examples, but one probably common is the cluster of devices at home from different manufacturers, and then you want to have a controller like Alexa or something, and then it needs to be able to talk to the various devices, and the devices may want to talk to each other, ending up in an abhorrent example of the fridge telling you that the milk is going to spoil. I think that's one of the most damaging and stupid examples of useless use of technology. But anyway, I won't rant and rave about it. But most of the today's standards, Internet of Things standards, are sort of concentrating in this area. Modeling real-world objects, defining the syntax and how the things talk to each other, which is all fine and dandy for the purposes that it serves. But what I'm interested in and advocating today is the semantic interoperability. Interoperability at the level of services and applications so that data can be aggregated across the things, across different domains, making applications portable and making large-scale analytics, machine learning, artificial intelligence, and all those things a lot more useful. And portable applications and services, I'll go into the details of what some of those are, but that's basically, so I'm talking about the other one. Not that one is better than the other, it's just there are two different things that address different problems. And I basically have the words here that say the same thing. I'll go lightly on this. Sometimes this device level is also referred to as syntactic interoperability, meaning you really have to understand each other's syntax. And to their credit, people who work on these things also try to solve a number of other problems, like being able to discover things and have them describe themselves, work on security in the system, worry about the management of the devices, all of those things that have to be in place and that have to be taken care of, which at semantic level you don't care. I mean, you don't care in the sense, of course, it has to exist in the real system, but at the semantic level you assume, conveniently, that all of those things are in place, provisioned, secured, connected, and all you now care about exchange of data among them. So that's a different level of concern. By the way, Internet Industrial Consortium, IIC, called this conceptual interoperability, basically being able to represent information in a way that is independent of the apps that have generated it and the apps that are using it, so that basically it has the thing. They have since given that up. They dropped it in the second release. They have kind of given up on interoperability. They still like the definition, but not that. And since it's become mandatory that we have to give an industrial sort of an analyst view of the marketplace, I'm shifting gear to make a different point is, so we saw which level of interoperability we're talking about. Let's see why that might be important. You know, I mean, important, it's nice, technically it's challenging, but is it a real world problem, and is there money essentially in solving that problem? I mean, is it valuable from the business point of view? So this is yet another study on Internet of Things. This one is from McKinsey. In my view, one of the best I have read on the Internet of Things in terms of its depth and understanding, not just throwing numbers and projections. Of course, they have their numbers and projections, that in 2025, the impact, now this is not just the IoT market, but the impact of IoT on the market is going to be somewhere between $4 and $11 trillion. And if you haven't been talking to economists recently, US GDP in 2016 was about $16 trillion. China is about 10 or 11. So this is basically the size of economy of China. Not to quibble about the numbers, you know, you can argue them all day long, but it's basically huge. That's the point. I mean, that's just to take care of. And one of the good things about studies, Rita's study also had the similar thing, is segmenting by market segment where they think the money is or will be. Right. So you can kind of see how they relate to each other. Again, the numbers I wouldn't worry about too much, but the relative size of one to the other, I think, is representative. And again, you can see that factories and automation is by far the largest. And the one with human health and fitness, the emerging thing, has a widest spectrum, and all the other good stuff, automotive and home automation, as you see, is not even at the level of automotive. That's the guess. But the reason I'm bringing this study up, and I have the link here that you can follow up, I mean, if you're interested, but they had like 10 key takeaways for the executives and from their study, and the first one was the market is huge, and they gave all of this number. The second, which is what I want to draw your attention to, is that interoperability, if achieved by industry, increases the total available market by 40%. So whatever impact you have is going to be 40% larger if the things are interoperable, or reading the other way around, if they are not interoperable, you're basically wasting away 40% of market opportunity. Again, whether it's 40% or 37.2 doesn't matter, but it is a lot. And it's fundamentally important. So and this is based on the experience with other industries and other consulting practices. It's not, you know, just made up. So it is important. And so again, this is just putting it in words. Why is this important? Well, you get that 40% TAM increase. You deliver on the big IoT data promise. One of my pet peeves is that a lot of people in industry are hyperventilating about the promise of big data, that many terabytes of data that the car can generate, that many cars times that many gazillions of bytes. And these are all incompatible data, yes. So a lot of data is not big data. I mean, it is big in the sense that it's large, but it's not big in the sense of it's diverse and useful. So in the sense you need both. So that just because you have a lot of data is not good. So there is that promise and expectation from IoT, and it can be delivered by having things interoperable, portable apps and services. And one other very important is, if you have interoperability, customers in a way own their data. They own the data in the sense that they are not held hostage and captive by whoever is providing the middleware or the data standard definition that they are using, right? They're not locked into a vendor, and they can do even things unthinkable to port your IoT data, let's say, from one cloud to the other. Try doing that from Microsoft to Amazon today, or the other way around. You basically have to give up all of your data loss because it's locked into their proprietary definition, and of course, not to mention proprietary systems, right? So that's sort of a contribution to the world. I was going to spend some time, but I basically won't spend much time in the sense, what are the real world examples of where people have already noticed this need and have to deal with it. In smart buildings, you already know that you have dissimilar silos of systems like HVAC, lighting, and occupancy. I know of several building operators who have a portfolio of buildings with different BMSs, and they would like to do optimizations across and use BKMs from one building to another, and they can't because the data are dissimilar, or they have to do their own translation, which is what they have done, basically paid consultants to do the custom. Smart cities are sort of poster example of having to deal with dissimilar systems acquired by different divisions in the city, different departments, lighting, buildings, energy, transportation. But in order to get the holistic view and try to optimize across the systems, or at least see how one influences the other, you need to have some data interoperability. And I've talked to a number of city managers who despair at the notion of having to pick a platform, meaning being stuck with something and not being able to work with the other systems. If things were interoperable, they wouldn't have to pick a platform, right? So that's the thing. And in industrial, of course, there is machinery from different vendors and stuff like that in the car. So basically, it is a real problem. So why not just have one standard and be done with it? And of course, we have Haystack, but not everybody uses it. I have heard that, at least not as of today. So I'll just talk a little bit about the landscape of standards. There are a lot of things in the running. But the general observation is there are a lot of them, and probably not one that wins it all. So there has to be interoperability across standards, not within one. So the one that you should be paying attention, if you are not, is OCF. It used to be called IFC or OIC, I'm sorry, Open Internet Consortium. Now it's Open Computing Foundation. The big players are, is Intel, Microsoft, Cisco, and it has also now merged with or acquired, depending on how you want to look at it, the All-Seen Alliance, which is Qualcomm and ARM. So basically, it's pretty much everybody in that space, and UPnP also is part of the specification. They're now merging the specifications, and they have IoTivity, which is not really a specification, but it's a very sort of public implementation of OCF. So it's a set of tools that can be used with, and a browser to browse existing and submitted proposed definition of objects. So it's very usable in that regard, I recommend it. So that's one major effort, but of course there are others. I work with IPSA, which works on top of lightweight M2M, which is Object Management Association Specification of Protocols, Manageability, Security, and all the other good stuff, used largely in the mobility and telephone industry. And IPSA defines the smart objects that work on top of lightweight M2M protocol. IPSA stands for IP for Smart Objects. So it provides the data model and definition of how that works. And as I said, we are now working, they have generation 1 definition of those objects. We are now working on the second generation, which would be the interoperable layer. But we, as I said, we have just defined what we are talking about, so it's not. There is, of course, Zigbee forever in terms of automation. This group probably knows a lot more about that. Bluetooth, that has some interesting definition for data pairing and interaction. As you know, your phone and Bluetooth devices work successfully. Then there is ETSI's 1M2M specification, which is an interesting specification. I don't know how much, there aren't that many products that use any of this stuff, and I'm not even sure how do you measure the take rate of different standards. Whether it's by activity, there is a lot of it in OCF. Whether it's by adoption, it remains to be seen. And of course, but wait, this is not all, right? There's World Wide Web, your W3C, the home of World Wide Web. They had semantic web effort for a while, and they have the sensor ML, and there are several other efforts, and Web of Things that I haven't put here, but there is basically activity. The HERE thing, I don't know whether you have heard of it, is a recent standard among the auto manufacturers, but it's really driven by a mapping company. The idea is to crowdsource the data from vehicles to get very detailed maps that are required for autonomous driving and navigation. You really have to know where the curb is and where the lanes are, not just what the road is and where it leads. And they want to crowdsource that, of course, from the cars and manufacturers across both makes and manufacturers. And they are defining the data format to do that. So it's interesting, more to illustrate, there are other domains to write. And of course, there are then okay, I'm sorry, my clicker. Then there is the old-timers, actually protocols that do have installed base, DDS and OPC in industrial automation. I don't know, you probably have heard of those. And of course, the Modbus and BACnet. And they do have installed base, which is the good thing. They have been around for a long time, which is also a good thing. I mean, sort of tried and true. But they, in essence, their architecture and philosophy predates the internet that we know and love. So some of them are based on Corba. May it rest in peace. We've been doing distributed objects with Corba for a long time. I mean, it's just a way that got I don't want to say replaced, but probably a better alternative solution is provided through the internet and stuff built on top of that. And another one uses essentially Microsoft implementation of objects.com and DCOM, which again is a little difficult to translate to today. So there are those problems. But in any case, those have to be mapped into the interoperable layer too. And finally, I'll bring to your attention, there are standards bodies that are influential and large, like OpenFog and IIC Industrial Consortium, with hundreds of companies literally participating, especially IIC is about 200 and OCF is over 100. But these guys, OpenFog and IIC, don't define standards. They are not standards defining bodies. They don't do definitions, but they do want interoperability. So they will adopt a successful interoperable scheme, right? So they are potential adopters if we go ahead and do these things. Okay, so this is, now we have said, okay, standards, probably we won't get one to rule them all, so let's work on interoperability. That's the whole point of this slide. And in terms of how you do that, you basically want to build on something like Haystack and mimic the way things were done on the internet. Separate protocol from the payload description and annotate things. And what firmware people and some of the guys who work on syntactic interoperability need to be reminded is it's okay to see a tag that you don't know what to do with, you being the application, right? When the application sees the tag or the marking that it doesn't know, it can simply ignore it. It's okay, I don't know this, so I can't make any use of it. But I don't have to crash and I don't have to panic. I can just go ahead and do it, right? So not everything has to be precisely defined and followed to the letter. You can just leave some things for those who need them and ignore them when you don't need. So there's a lot to learn from the internet, and it should be. So before I go to say, okay, let's go ahead and do this interoperable thing based on Haystack, which I'm going to do at the end, is this thing feasible? We say, okay, make things map across all of these different standards, but does it really, can it be done? Are they close enough or similar or dissimilar so that it's not really practical? From the sort of conceptual point of view, of course, it should be possible because they are all mapping the same physical object. They are mapping sensors and thermostats and pumps and valves, and those objects are the same regardless of the way you model them, right? So the only differences between the standards would be slight difference and variations in modeling. They should be able to be mapped to a common thing that is close in representation to the real thing. So in order to test the theory, though, we did a Interop POC where we connected a number of about 3 gateways in different standards. I'll just show you. Connected a bunch of common sensors, temperature, humidity, current, flow, but encoded the data as they were acquired in real time in 3 different standards. As I have it here in IPSA, one was in IPSA, one was in OCF-OIC, then the specification, and one was in Haystack. And we then converted that in another gateway to the common interop definition. Okay, we made one up for the purposes of that thing. This is what I'm advocating a standards body should do. But the idea is those are the ones meant to be available at the API level as you retrieve the data from either cloud, the database, or it could have been directly from this conversion gateway. And by the way, the conversion function is also sort of, it could be anywhere in the system. It doesn't really matter where you placed it. We put it in a separate gateway just for the fun of it, but we wrote it as a container function so it could run either on the cloud if you wanted it, or even in the gateways doing the native translation. That's immaterial. And so after peddling this chart for a while, then we got funding and we actually did the thing. So this is from one show in Barcelona, actually at the World Congress later on. And here are the 3 gateways. They were actually based on Intel Galileo boards, the beauties of Internet of Things. You can get cheap prototyping. With Arduino extenders, and basically these are some of the sensors, discrete CO2 and temperature, humidity, and we use some professional sensors just to show we can do that too, from with 4 to 20 milliamps, the standard thing. These were various that actually I got the samples last time I was at Haystacks that do temperature, humidity, and CO2. These are professional ones that you install in buildings. And, oh, by the way, I'm sorry, I forgot that. We also did the UI, so the gateway that was doing the translation was also generating the UI, which I'm showing a screen here for. You don't have to, of course, generate it from there. It could have been generated from cloud or anywhere else. But the point is it generated the UI to demonstrate what are the, and the way this works, actually the links, when you look at the presentation, these two links point to the actually live version of this. We are running this for the purposes, but I didn't want to get lost in that because I want to make a particular point which is easier done on a static slide. So the way this works is the UI constantly cycles through the readings of sensors. This is dynamic readings. It highlights the sensors that it's reading, and the highlighted field, meaning it's currently reading the IPSO and translating it to the Interop version. Then it reads all of the IPSO sensor, translates each, then the same set of physical sensors from OCF translates that, and then the same from here. And in this sort of grayed out, it still gives what was the last reading of the equivalent sensor from this and this gateway. So you can do that for comparison. So here is just, since this is the Haystack crowd, you probably, this is easier to read, and here is the Haystack version of it. It basically says this particular thing is a temperature sensor. It measures the air temperature. We didn't say that here. It reports in Fahrenheit, and the reading is about 78 at this point. And here is the timestamp. And of course, the unique sensor ID. We put this GIPSO stands for Gateway IPSO. I mean, we just made up the names. The only important thing is that it's unique, so that's it. And the reason this is number is IPSO uses the convention of being built on lightweight M2M and worrying about the size of the payload, uses numbers to indicate fields. So 3303 stands for temperature sensor. So you kind of have to translate that. And 5700 stands for the value, and 5701 is the indentation. But they are still key value pairs, right? So the key is 5700, meaning the value. And so here is your reading of the sensor, and then you would be getting it in the other ones. And we have done it for the sensors that we used were water temperature, air temperature. This was supposed to emulate chilled water temperature, so we dipped them actually in things. Humidity, CO2, and current flow. And basically we found out that things can be done. You know, they are similar enough, they represent the same thing. And we found some discrepancies, some nuisances that you encounter when people strictly model the objects and force you to use a particular formulation. For example, one annoying thing was two of them, I will not name names, don't even have the definition of the timestamp, right? So you kind of have to make it up, and it's outside of standard. And it's pretty useless to have sensor data without the timestamps. The other thing we encountered, which was annoying, is one of them reports the value of CO2 as only true or false. You cannot do the parts per million reading, which is what the sensor gives you. You have to translate it to true or false, meaning it exceeds the dangerous level or it doesn't, as per, you know, something. So you basically have to drop the data that you have in order to comply with the standard. So, you know, losing data is not what modeling should do. Anyway, but the thing is feasible and it can be done. And so I just want to highlight what I think, how this can be done. And I think this is the discussion we can have tomorrow. I talked to Brian, and we can add it to what to do next with Haystack. And I'm suggesting, regardless of Haystack, a standard body has to add the Interop mission to its charter. It says, okay, we do our definition, whatever it is, and we will help shepherd this interoperable thing that makes us work with other standards and others work with us, sort of independent on the standard layer. Simply because this interop format has to be defined by somebody in a way that a number of people find usable and credible, right? And ideally, there should be some tools to prototype things or to do, which, for example, Haystack, OCF has very good tools, and so mimic and emulate something like this and find a way to contribute. That's sort of more of the logistics. In terms of politics, unfortunately, which you have to play with standards, we have talked, and I have talked to a number of other standards, basically in addition to proof of concept and call to collaboration, but there should be a formal collaboration between standards working on this. We have had some discussions with OCF and IPSO and Haystack. NW3C, I plan to have some, so basically we have to find sympathetic people. You want people who are relevant, who think in this domain, and who want to collaborate. You know, not everybody wants to. There's politics. And I think it's also good to approach early on, we're working on that too, interop adopters like OpenFog and IIC, basically alert them and make them possibly participate and support the effort. And it always helps to have some patron saints, so getting some good corporate backers. I think Intel is interested in supporting this, and ideally some combination of technology, and others are more than welcome, I mean, you know, to form the group and come out with it. And ideally some of the users, I have talked to several users who want to support behind the screen, but who would not necessarily go in public of doing that, but it's good to have that level of requirement. And as I said, again, it's similar to Haystack, and it can be done. So basically, this is my summary and conclusion. All of these things that we told you, interoperability is at the service level. It's very important. I mean, it's important both from business point of view, a technical point of view. We should work on interoperability across standards. Probably Haystack is a good place to start that movement and work with IPSA and others. And so the call to action is, let's do this together. I'll participate in several sessions, but in particular the one on the next follow-up on Haystack, and I would love Haystack to be basically one of the drivers, if not the initiator of this thing at the cross standards level. Okay, thank you, that's all I have.